Hi everyone, welcome back to the channel. Today we're diving deep into Solana programs and smart contracts and the various sort of components of an Anchor program, and Anchor being sort of the framework that facilitates the development of Solana programs, or as I prefer the term smart contract is cooler, I think, borrowed from the Ethereum world. So as you can see, we have a packed agenda today. We're going to start with a brief disclaimer at first, then we'll jump straight into an Anchor program sort of series of commands so that you can get familiarized with the Anchor CLI. As with any other software application nowadays, it comes with its own CLI, right? So the Solana has a CLI, Anchor has a CLI, everything has a CLI. So we'll start by going into that, and during that demonstration, I'll show you the various commands that you need to know, but also what's the general scaffolding of an Anchor program that gets generated initially. And this is where you start basically developing your smart contract. Then I'll go straight into a demo of the Maia SOLful Cellars decentralized application. So this is the e-commerce platform that I've decided to build for my business. I think it's useful for you to have like a good understanding of what we're trying to achieve. And so I thought, you know what, let's start by showing the app as I have it up until now. Like, I only built a few screens so far, but at least it gives you an idea. The screens are not polished. It's not a beautiful polished UI. I will probably change it a few more times before I actually go live, either later this year or early next year. But the point is, the app is there to just give you a sense of, what the finished product will look like. And also, you can better empathize with what the code is trying to do if you've seen the app already. So, and I'll describe what the main interactions with the Solana blockchain are going to be. So the app basically gives you a lot of flavor for what's to come. One of the other things that I'll do once the demo is finished is I'll start this talking a little bit about the different account types that I've created for this particular app. And again, one of the reasons I like to use this application is because it's a real world app. It's not just a mere example. It's something that I'm going to use for my own business. So it makes a lot of sense to use something practical and meaningful, and something that is like a little bit more complex than just a random example application. One of the other things that I'm going to be then talking about is doing a little bit of an overview of the anatomy of an instruction. What is an instruction, a Solana instruction within a program, and what are the key components of an instruction and the context that the instruction receives and all that. And finally, I'll finish this by talking a little bit about architectural concerns. So one of the things that I've seen in many of the videos that I've watched online is sometimes a lot of time is dedicated to talking about the ins and outs, like the nitty-gritty detail of the programming language like Rust or the Anchor framework. But too little time is spent talking about like the general architectural concerns and how should we design the application. What bits, for instance, should be on-chain versus off-chain? Is there like any rules of thumb? So this is, I've not read this from anywhere. Like, this is my own personal experience and things that I've stumbled upon as I was developing the application. And I was like finding, okay, maybe I should keep this there, maybe I should keep this here. And realistically, I want to get to a point where the application is practical to use, but also get to a point where it's well architected. It's not just a random application that was put together from random parts and no thought had been given to where each of these parts should be. No, I want it to be something that kind of makes sense, and it's trying to optimize for certain goals, cost, performance, UX, things like that. So yeah, so let's get started. It's a packed agenda. I'll try and keep this as brief as possible. I'm gonna try and finish this within half an hour. Probably it's not gonna be half an hour. It's gonna be a little bit more than that, maybe 40 minutes. But I'll try to keep this as short and sweet as possible. So let's start with the disclaimer. So the disclaimer is basically this is not a Rust programming language sort of course or guide. This is there are fantastic resources out there that both on YouTube and other training courses online that give you deep insight into Rust and the Rust programming language. Today we're just basically focusing purely on what you need to start coding a Solana program. So I'm not going to go into the what's a Rust lifetime, what's the lifetime concept and things like that. So suffice to say that Rust is a very different programming language compared to the likes of C# and Java and Dart, etc. There are not direct parallels between the two languages. It's not just a syntax difference. There is more to it than meets the eye. And so there is a lot of, I feel, coming from other languages, I feel this is closer to what I experienced when I first started my programming journey. Back at university when I was doing C and C++ and God forbid assembly and things like that. So all of these languages are really low-level languages where you need to manage memory manually and things like that. So Rust is closer to those than it is to higher-level languages like Java, C# and Dart and any of the other languages. So bear that in mind when you're trying to learn Rust. I'll just leave it at this. When you're trying to learn Rust, be prepared for going back to your, if you come from that era of programming, that lower level programming languages and having an appreciation for those will make it easier for you to actually understand Rust. Yeah, so that's it. Disclaimer out of the way. Let's get started. Let's talk about Anchor. So Anchor is a framework which simplifies the Solana smart contract development lifecycle. I will show you some of the command line instructions that you need to be aware of. Some of them are listed here on the slide. You can see there is Anchor Init. So when you do Anchor Init, then the project name, it creates a folder structure with all the files in it. I'm not going to do Anchor Init in this particular demo because it would take a little bit too long, but I already have done Anchor Init just before this video, and now I can show you the output of doing that Anchor Init. Then we can do Anchor Build. Anchor Build is just simply compile. So you've developed your smart contract, now you're ready to compile, you can do an Anchor Build. Then you have Anchor Deploy. It does what the name says. It basically just takes the binary, the bytecode, the BPF bytecode, Berkeley packet filter, I think that's what it stands for. But it's basically the bytecode that the Solana virtual machine sort of interprets and needs. So it takes that binary and basically deploys it on the blockchain. And finally, you have also Anchor Upgrade, which basically is to replace an existing one, an existing program. So again, for expediency, I'm not going to run all of these commands, but at least you know they exist. I'm just going to show you the general scaffolding that you get once you run Anchor Init. And I'm not going to spend too long on that. I'm just going to point out like a couple of things in there, and then we'll jump straight into the demo. of the Maia SOLful Cellars decentralized app, and we'll then do a little bit review of the structs that I've created for that application, and then the anatomy of an instruction. Right. So, shall we get started? What I will do is I will fetch my Visual Studio Code window so that we can get started reviewing the empty sort of folder structure with all the scaffolding created by Anchor Init, as we discussed earlier. So just bear with me a second while I find the right file and switch the screen. Here we are. So this is not actually the right one that I want. I'll come back to this one in a minute. The one that I want to show you is this one. So this is the empty. So when you do Anchor Init, this is what you get. You get this folder structure where you get, and inside the Anchor test one, which is basically the name of the project that I ran Anchor Init with, you get this lib.rs. So this is where your smart contract will live. So most of your code will be in this lib.rs. Three things of note here. Again, I'm not going to spend too long here because I want to really dive deeper into the details of this in my e-commerce app. So just to call out a few things. So declare ID, and then you see an address here. So this is the address where, when the program gets deployed in the blockchain, this is where it's going to live. That's his home in the blockchain, in the Solana blockchain. The other things to note here, so this is your smart contract, right? And then inside the smart contract, you have this function, which is kind of the instruction, I think, in the Solana terminology. And this instruction is called initialize. So as you can see, an instruction receives a payload. The payload, like one of the first arguments that you'll see, super important, is the context argument. Again, I'll go into more detail on this when I show you the more sort of meaningful code in my e-commerce platform. But effectively, you receive a context, you receive a bunch of other arguments sometimes. And the context is basically just metadata for the instruction. And then you can see that this struct initialize here is defined here. And then, again, I'll go into more detail there, but this, generally speaking, lib.rs is where your smart contract, Solana smart contract code will reside. The other word you mention here is this anchor.toml. So a couple of things here. Again, you will encounter this. This is the declare ID sort of long string that you saw just now on lib.rs. This is the program ID effectively. And the other wordy sort of thing to mention is this provider section where you see the cluster. So this is where you will point Anchor to your local Solana cluster. So you run your own local test validator there. I think I even had like, let me just show you, where is it? Is it here? No, it's not here. Anyway, let me just see. Yeah, so this is the log. So this is, yeah, I'll show you all of this later. There you go. Solana test validator. So this is when you run this. So if I run this now, you will see that it's effectively initializing a local, there you go. So this is the local test validator. And this is basically a way for you to test your own Solana programs directly within your machine. You don't even need to connect to some external devnet, testnet, mainnet, it's all here. This is great. The only limitation that I found with this, and I'll show you that in a minute, is that when you want to test with integrations like with Phantom Wallet doesn't have an option, at least as far as I've seen. If I'm wrong, please let me know in the comment section, but I've not seen an option to connect Phantom to a local host. It only shows DevNet and testnet, so that's why. But apart from Phantom Wallet integrations, for example, everything else actually works beautifully. And I highly recommend, of course, that you try to debug your program as much as possible with a local validator. And then, once you're ready to move to the next level, that requires maybe DevNet, then obviously move to DevNet. DevNet obviously is the next logical choice. But yeah, the local validator, as you can see, it's quite easy to spin up. I'm going to stop it now because we're not really going to use it. And then you have the Solana logs. This command is actually then basically it starts producing logs in real time. So anytime I tried, for instance, to deploy a like anchor deploy, would start printing a bunch of information in here because it shows information about the new program being deployed. Or for example, when my client-side application connects to the local host, to call some instruction, then again, I would see evidence of that happening here in the logs. So anyway, not going to show you that today here. Maybe that's going to be the topic of another video. But for now, just bear in mind that, the Solana CLI allows you to obviously do the debugging as well. And especially the local host is obviously an interesting choice because all the logging is only your logging. So if you're doing this in DevNet will be, it's a wall of text just basically continuously scrolling. And that means effectively that it's difficult to pinpoint, your logs from other people's logs. Now, of course, you can filter this. You can, you can filter the log output to just show you your program ID, but you still sometimes miss a few things because there is so overwhelming stream of logs being generated because so many people are using that cluster. While this one it's only your cluster, of course. Right. So I think I've talked enough about Anchor CLI, Anchor commands, and Anchor. The Anchor sort of general structure that we saw here, etc. So now it's time, I think, that I show you the application that I've built. I'm not going to show you all the roots of the application because, again, that would take too long. I'm just going to show you the critical ones, the critical path, let's put it like that. I'm not going to show you, for instance, path where the app where you have installed the app for the first time and you don't have an account, user profile account already created, in which case the app would start by asking you, so let me show you. So let's start with that. So if I go to my Flutter, so this is the, no, this is not the one that I want. I want this one here. Yes, that's the one. So let me start by describing this. So first and foremost, this is the Android emulator that I've installed on my Mac. I installed the Phantom application straight from the Google Play in the emulator itself. It's beautiful, but it does work as in a normal sort of physical device. And so now, and this is basically the account that I'm going to be using for doing this very, very brief demo. So if I hit F5 here, right, and I'll show you this. So there you go. So this screen, so you wouldn't see this screen when the app starts if I had started with a fresh install of the app. Because at that point, so the app already recognized that it has run before. And so at that point, what you would see is a wallet selection screen. I already selected Phantom as the wallet, so this is why it's not showing that screen anymore, because it remembers. So if I now do connect, what this will do is it will connect to this account that is currently selected, of course. Oh, by the way, almost forgot to mention, if you click on this cog here and you go to developer settings, you can see here that you can enable testnet mode. And then here you have these two values, devnet and testnet. As I was saying earlier, there is no localhost sort of option here, so that's a bummer. But yeah, this is useful information to know. So now, so let's start the, so the application obviously is already started. So I can just click connect. I would normally see the icon of the application here. I was seeing it before, so maybe there is something wrong with Phantom at the moment. So anyway, click connect. Right, so what you're seeing here is, so a couple of things happen here. When the app connected to, when I click connect, the first thing that happened is the Phantom application gives me, as you can see here, the public key of the connected account. So that's cool because I will need that key for a multitude of different things. One of the things that the app does initially is of course, it tells you, it asks the blockchain, is there a user profile already created for this user? If the user profile doesn't exist, instead of seeing this list of products, you would see a create account button here. I'm not going to show you that because otherwise it would take too long. But effectively, that's what you would see. You would see a create account button, you click create account, and then at that point, a new PDA, program derived address, remember that, a new PDA would be created for that user as a new user profile. It's kind of like, it contains just a very brief information, two things, like it's the wallet, the public wallet address of the user, as well as the encrypted delivery shipping address details, which only get populated when the user finally commits to making a purchase. So in this case, this account that I'm connecting to, the account number 2 in the Solana app, in the Phantom app in this emulator, already had done that. Like I already had created a profile, so that's why you're not seeing that. So now you're seeing here 2 bottles of wine. By the way, like the whole idea for this app, for me personally, came from the fact that I own a farm. It's an historic farm, very beautiful farm, and it has a vineyard. I've been planting some grapes there, some vines there, and they will be, for the first time this year, hopefully harvested, and I will be creating a new range of wines that will basically be sold, or I'll start sort of, if they have the quality that I expect, they'll stop being sold next year, somewhere around this time next year. So in a year's time, let's say. Because obviously they need to ferment and age and all that. But anyway, too much detail. These bottles here are not my bottles. These are from another producer that I much love, Kazakh. It's fantastic, a fantastic range of wines. So both of these are some of my favorite of that region of Portugal. So anyway, too much information. So, and by the way, these details here are not associated with these bottles in any way, shape, or form. This is just as an example. So just don't pay attention to the details at all. It's just random stuff that I've put in there just for testing purposes. So, but let's say click buy. Let's say I want 1 red and 2 white. And now I place the order. Now, because for this particular account number 2, I never actually placed an order before, and I never actually saved any shipping details. That's why it's asking me. If I had already done that, it would not ask me again. It would just go straight into the order confirmation screen. But let's do that. So let's say it's United Kingdom that I'm located. I'm in London, and let's say the road to success number 1. So this is the fake address, and I'm gonna say I want the delivery method to be express because I can't wait for my gorgeous wine. And I'm going to do order confirmation. So now the app obviously connected to the Solana blockchain, and it sent actually a transaction which contains two instructions: one to transfer the SOL amount that was shown on the previous screen, and one to create a purchase order PDA in the Solana blockchain. This is not great, but never mind that. Let's confirm. Actually, there is something wrong in here. So as you can see, it's 0.6 SOL. Let's try again. Maybe we'll get lucky the second time. Hopefully we get lucky. Come on. Okay, there we go. This is what I wanted to show you. So maybe I have a bug in there in the code, or maybe it's the DevNet that is having issues. Anyway, I'm glad we got to this point. So this is the transaction ID of the purchase order sort of being successfully created in the DevNet blockchain. Let's put it like that. So the idea that I've put this in here is that the user can now click on this if they want to click on this, and it would open the Solana Block Explorer, SolScan, and it would show you the transaction details. And one of the things that it would show you in these transaction details is the amount of SOL that was transferred from your wallet as a customer to my wallet as the admin or the owner of this program, and also the purchase order creation, which is a PDA under your profile, right? So anyway, it seems like the SolScan is currently just not working for DevNet, unfortunately. So let's just kill this for now. Right, so I've shown you the app, or at least kind of the key concepts of what the app is trying to do. Now, let me show you the smart contract element of it, which is the more the part that is kind of the focus of today's video. And it starts with the constants. So as you can see, so it's a similar structure as we discussed initially with that empty scaffolding that Anchor Init created. But this now is obviously populated with my own stuff that I created. So this is the program for the app that you were just seeing. Nothing special to see here. So these constant strings are going to be used for the seeds of the accounts that are part of the context for those instructions. Again, this will make sense in a minute. The thing to note here is this admin public key. So this, by the way, all of these keys are going to be changed when I go live. So it's, even though it's a public key, everyone can see it, but it's always good practice before you go live, change all of your keys, change all of your, make sure that your security is as tight as it can possibly be. So, public keys, everything change. But bear that in mind. So this public key is important because it basically tells the program that only the administrator which owns this key and actually is capable of deploying this contract can do certain instructions, and that's why this is here. And also the client-side application, in my case the Flutter application, also needs to know about this key. Which again, because it's public, it's fine. It can be in the code, no problem at all. So the other thing that I wanted to show you is the element where the file where I basically put all of my account types. So all of these definitions of these structs are types that are going to be stored in Solana. You can see the admin, you can see the customer, you can see product, you can see purchase order. So, there are lots of things in here that are part of the e-commerce platform application. But the one that I want you to pay special attention to is this admin one. So the admin is actually a collection of counters and stats for the application as a whole. And for example, for instance, suppliers. So I allow different suppliers to sell their products on my platform. So it's not just for my own products, but also other suppliers that want to sell it on my platform. And I allow them to create their own accounts and have their own products in here. One of the ways that I am tracking this when I create a new supplier is this supplier, the last supplier. So this is like an index, like in a database where you have a account, an index of every time you add a new entry, you have a new that index gets increased by one. So this is effectively the same thing. As you can see, this is a convenient way so that when the instruction runs every single time, it can query this to see, okay, what's the last one? Okay, so I'll just add one more. And, I've applied the same strategy across a number of other things. You have for suppliers, you have for shipping rules, you have for promotions, you have for products, you have like for a bunch of stuff. So, I'm not going to discuss now, like, these are the types: unsigned integers, strings. There is nothing like public key. So there is nothing here that is like fundamentally like complex. This is an array of a more structured type, which I have here. But anyway, this is like similar to classes in more, in classes like C# or Java. But don't get too distracted with the syntax. The concepts. The paradigms are similar in this respect. So if I now show you the smart contract. So again, as you can see here, declare ID. So this is where the smart contract is going to live in the Solana blockchain. And now you can start seeing the instructions. So actually, let's start like decoding what this instruction is doing. So this is actually one of the first instructions that I've ever created, like that I created for this particular smart contract. And it's called add admin. So this is basically creating the admin account. And this is the so-called anatomy of an instruction that I want to talk a little bit about, because as you can see here, it contains the context, which we alluded to earlier. The context, it's like metadata for your instruction. But one of the most important things that the context has is the list of accounts that your instruction is going to need to read from or write to. So any account that is needed either for reading or for writing or both, that account needs to be included in the list of accounts that are going to be supplied as a payload for this instruction. You should think of your smart contract instructions as stateless, because they need everything they need to conduct their operation needs to be supplied as an input. That's it. There is no memory, there is no state being kept anywhere, right? So that's one element to bear in mind. The other one is this. So the arguments that after the context, the other arguments, the remaining arguments that might exist after the context are typically values that you need to update your accounts. So any new values, like for instance, you saw the shipping address. So if I need to update the customer records with an encrypted shipping address, I would expect to receive it here. And then that value would be stored in the blockchain, obviously encrypted, because the blockchain is public, so we can't store, sensitive data in the clear. That would be a big no-no. But yeah, so that's that. And this particular instruction is actually one of the simpler ones. I have other instructions here in the smart contract which are much more complex. But this one, as you can see, it's doing, it's using this message macro from Rust to actually logging to show some logs. By the way, these are going to be shown in this log stream, right? Don't don't pay too much attention into this. I'll discuss this in my next video, but this is like a security check, a more manual security check type that you can do. But yes, you know, as you can see, I am initializing the admin struct, which again, it's this one, right? So the instruction to initialize the struct is basically doing all of that here. And the only field that it could not infer on its own, it has to receive it by via the argument. One of the other things you will see is that this context is associated with a type, and this type, if we go to the definition, which is this one, this type has to be defined like every time you have an instruction, you have to have the associated type for the context. And this is where you list all the accounts, right? And this is where you can see that if you were not using the Anchor framework, and by the way, I've not developed actually smart contracts not using the Anchor framework, but I know that there is a lot more from, you know, watching and reading some documentation. There is a lot more boilerplate code that you would need to be developing to validate those accounts that you receive, to do additional check. And with Anchor, like deserialization, like all of that stuff gets hidden away because Anchor is doing that. Like Anchor is validating that the accounts that it's receiving conform to the definitions that you have given it. It's, you know, for instance, in here, it's confirming that the authority, the first account that it's received, you know, the very first one is the signer of the transaction and that it has a valid signature. So Anchor validates that. In this case here, for instance, the admin profile is the PDA, the the program derived address that is being generated via these seeds. As you can see, remember, this is a string. This is the public key, which is a sort of a sequence of bytes. Then it's using that to generate the admin profile. In this particular example, for this particular application, there will only ever be one admin account. Don't get too lost in this space, but it just the one liner on this is we need to be incredibly efficient with resource consumption in Solana, and especially with space. So accounts, when they get created, we need to tell the runtime how much space we need when creating these accounts. And so we need to be incredibly efficient with our choices. And this is what this is doing. It's basically saying, again, I'm not going to go in. I'll explain all of these numbers and all of these things in my upcoming video. But effectively, that's it. That's what it's doing. So, and then you can see the system program here, which is one of the accounts that it always needs, at least in most of my structs that I've done so far. Kind of the system program needs to be there for a number of reasons. But again, I'm not going to go into that detail right now. As you can see, summary, closing statement, the admin instruction needs a context, and the context is basically needs, has as part of its metadata a list of accounts, and these are the accounts that you would find in there. So that's all I wanted to really show you for today in terms of code. I think this is enough. Like I have like a ton of stuff in here. I'm not gonna, a lot of this code, I will be showing you the code in upcoming videos and homing in on certain things that certain instructions are doing. But for the time being, I think this is enough for now. Let's jump back into the slides and I'll be talking to you a little bit about some architectural considerations that I think it would do you good to consider when you're developing your Solana smart contract, because I don't want this just to be about the syntax. As I said in the beginning, I want this to be more broad. Take a step back, look at the big picture, look at what you're trying to achieve in building your DApp, and then let's go from there, right? So let's go back to the slides. Right. So, okay. So when developing these DApps, one of the key architectural considerations is how you balance your on-chain and off-chain data. So you want to store, I would say, core critical data or dynamic data on-chain. Optional or static data can be stored off-chain. This could be in a decentralized storage solution like Shadow Drive, which is the one that I picked for this particular example. So all of those images and product metadata that you saw there, part of that, like the images definitely, and some part of the metadata associated with the product, the bottles of wine that you saw, was coming straight from Shadow Drive. I can do a video on Shadow Drive some other time, but trust me that that's where it's coming from. A crucial point to remember is that off-chain data should always be considered optional. And let me explain what I mean by that. So off-chain data, if off-chain data were to become temporarily unavailable, the core functionality of the DApp should, like placing orders, for example, allowing a customer to place an order, should remain intact. So the only impact, of course, for the front-end application would be a loss of visual interest, right? So there would be cosmetically, for instance, maybe I don't have pictures to show you. I can only show you the product names, but at least the product name is there and the product price is there. And I can allow you to buy still the product. So that's the thing. So it's a less polished user experience, but it would not disrupt the essential operations. And that's kind of what we're trying to achieve. We're trying to optimize for cost on one hand, so we don't want too much information on-chain because on-chain storage is more expensive than off-chain storage, typically, although with compressed accounts, that might change things considerably. And I know Solana has some ZK compression, I've read about it. Then you have and then you have obviously sorry, I almost lost my train of thought there, sorry. So yes, you're trying to optimize for cost, you're trying to optimize for performance, and you're trying to optimize for user experience. Guys, I know it's easy to, if you're like an engineer on the backend side, you're kind of thinking, yeah, I mean, I need UX is not my main consideration, but yes, you need to consider that users, when they're using decentralized applications, they often they draw parallels with their Web2 counterpart applications. And if this one introduces more friction, this is probably not going to be their main choice to use going forward to buy whatever they need to buy. So we need to make these dApps as frictionless as possible, or at least as frictionless as Web2, if not better than Web2. That's the way we win the game. So I made some choices when it comes to, for instance, product data. I kept the names and the prices on chain, but the product images and details about like wine grapes used and a year of harvest, things like that, that is kept off chain because that's more optional. For things like purchase orders, they are kind of the metadata associated with the transactions, so it made sense for that stuff to be on chain. And it's also tamper-proof. Like if it's on chain, cannot be manipulated. For transparency's sake, it's excellent that that stuff is on chain, so it makes a lot of sense for purchase orders to be on chain. And one of the other things that I would say the key consideration is like the querying of the data. So it's always a good element to consider when you are like in your back office operations, for example, if you need to run a report of all the purchase orders that have not been fulfilled yet. So they've been placed, you've received the money, but you've not shipped the items out. You want to take a report out. Like what are the data fields that you're going to be using to query the blockchain. And these things are better to stay on chain because it makes the querying a lot easier as opposed to kind of keeping them off chain. So things like this, I think, are always, you need to weigh the pros and cons, the cost, the performance, the usability, the UX, like all of these things come into play when making decisions on whether things should sit on chain or off chain. And finally, I just wanted to sort of briefly state that there is a logical sequence for developing a decentralized application. Things do not need to be done in this order, of course, but I found this helpful. So, first you create the off-chain metadata, like the images that you saw on the bottles of wine, for example, and you create the metadata, the JSON files associated with the process, like you create all of that. Then you create the admin instructions, because the admin instructions are going to be creating data that your customer-facing instructions are going to need to function. So you create the ad admin, the ad product, add promotion and shipping rules and things like this. Then you create you don't need to create the admin DApp front end. Why? Because you can use things like the Solana Playground to act as your admin decentralized application. So that's great. So that can wait. I'm now building the admin DApp for this particular application, but for the longest time I've been using the Solana Playground. It's a fantastic tool. And finally, after that, you can build your customer facing sort of instructions, like add customer, like the one that creates the customer profile, or add purchase order, the one that you see when the customer finally places the order. So those are instructions that are triggered by the customer themselves. So that's that. So one final point before we close. So when we are working with Solana programs, one thing to bear in mind is how changing one account relates to or affects other accounts that might be related to that one. So when you update a field in one account, you need to consider if it triggers changes in other accounts. And if they do, then those accounts need to be passed as part of the payload for that instruction. The other thing is the Solana programs, each time you are, let's say, creating a new purchase order, I would highly recommend that you go. A good rule of thumb is to review the account type, like in this case purchase order, and go field by field and determine whether any of the fields require input from the client application to initialize it. So, for instance, if I need the customer shipping address as part of that, is that coming from the client account? If yes, then that's an argument in the instruction, and also an argument probably in the context struct that you define for that instruction, because you will probably need that argument to calculate the space required for that account. You see where all of these things are linked together? So generally speaking, it's always a good idea to match the arguments that you have in the instruction with the arguments of the context struct definition. You will see that in the next video that I'm going to create. So we're just about finished. So looking ahead, in the next video, we'll dive deep into Python coding, evolving the account types, and what kind of associated errors occur when you try to evolve, like grow your types. Like maybe you forgot a certain field and now you want to add that field to the type. So what kind of errors might occur if you're not careful? So those things, I've experienced those things and I can share them with you. And how do you implement role-based access control with Anchor? So this is one of the key beautiful things about Anchor, is that it makes it so super easy to do security checks with your instructions. So definitely worth spending some time in the next video talking about how Anchor facilitates all of this. So that's it. This video has ran for way longer than I wanted, like it's 49 minutes running now. But thank you for bearing with me. all this time. And if you find this video helpful, please subscribe, hit the like button, and ring the notification bell so that you don't miss any of my upcoming videos. So stay empowered, stay decentralized. Thank you very much. Bye-bye.